we are talking about Pyreverse. So many sessions we have discussed about Pyreverse and we have generated the reverse engineering. So Pyreverse is a simple tool which does reverse engineering of Py, that is Python code, and it generates the hierarchy, inheritance diagram or containment diagram. These are the two features in any design. So it passes the Python code and generates inheritance and containment diagram. So we'll see. So Pyreverse is a kind of reverse engineering tool. So we will proceed for the Pyreverse on the code or the graphical code that is called Tkinter. So if I have a Tkinter code, then we would generate reverse engineering UML diagram, Pyreverse through Pyreverse. We have our own script. That script would first see if it has Python code also. It will generate it to Python, and then it will run Pyreverse, and the data that returns from Pyreverse, then we will augment the data, and we will see that whatever is not required should be washed away, and whatever the class we are looking into, that should be highlighted, and its methods and its attributes should be placed nicely. And the biggest thing is, if we see Pyreverse, it is very good in containment and parent class diagram. So if I have a class called widget, then widget contains something, it will show. Widget derives from something, it will show. But whatever are derived from it, then it won't show. So in our enhancement, in our augmentation, if I have a class, its parents, its containment, its contained, and its all children, that we will also list. That is kind of highly useful when we see the architecture. Like we can just go to the base class and we can just see that how many classes are derived from it, and from them how many classes. So all classes to the every children live, that will see. So Pyreverse on Tkinter, containment, inheritance, and all its subclasses, everything that will see. Further to discussion on Pyreverse Tkinter. So we will proceed now. This is Linux Mint. Okay, so we'll proceed point by point. So this is the agenda. We would run Pyreverse, reverse engineering tool on Tkinter code base. We'll install Pyreverse and GraphBase. GraphBase, Pyreverse for Pyreverse, and GraphBase is for drawing the dot line and a rectangle and so many diagrams. That is used in UML diagram generation. Copying Tkinter code and then we'll run Pyreverse. We'll do further beautification through fix modify. That is kind of a custom tool that is our generated. Okay, so attribute wise, if we draw the diagram, UML diagram through Pyreverse, it looks like this, whereas through only class, no attribute, it looks like this by default. So step by step, what we would do is, we'll copy the Tkinter code, install Py in GraphBase, set the Py Python path. It may not be necessary if we execute from a particular directory. Pyreverse, then we'll run. And if it has a Python code, then we will run fix that would convert Python to Python, but I don't think there is a Python code here. And then we'll do the beautification. If we do the beautification, this is the primary graph that we get through Pyreverse. This is class diagram, and where this is class diagram that is kind of a panoramic with all the attributes, and this is only class diagram, skeleton. If we use beautification, then we get skeleton. These are the skeleton, whereas we get the attributes also. These are the attributes of Tkinter, and extra we get the derived class. So if there is no derived class in the Pyreverse, only parent class, and this is attribute, and this is a skeleton. There is no attributes in the base widget, but through a custom tool we have attributes also, and we have extra, that is all the derived classes of the base widget plus the skeleton. So, and it is highlighted through red color boundary. If we see the derived classes, then we get actually all the list, like Tkinter top level, and then dialog is derived from it. Further dialog is derived from it, and then float string, similar to widget, button, canvas, like this. So we get all full diagram. So this is the derived class that we get extra through the custom tool, and all the derived class. Okay, so we'll go step by step, we'll copy the Tkinter code. Okay, so we'll go to temp, and we'll create a directory called Tkinter. It's an empty directory, it has nothing. And if I run Pyreverse, okay, there is no Pyreverse. So we will install sudo apt-get install pylint. We'll try Pyreverse again. Okay, so machine has Pyreverse now. We'll install GraphViz similar way. Okay, now we have both. Now I can do man on Pyreverse. Okay, so we'll see the point by point what it is. P is project name that we don't need. What are the files that we want to ignore? Don't need. Then we have mode. What all we want, we can think about all. No filtering. Okay. Diagram definition file we don't need. Class diagram, we'll draw the class diagram. How many level of ancestors we want? Okay, so we'll say all ancestors. How many level of association we want? We'll say all association. Built-in objects. Right now we don't want, otherwise it will be kind of clumsy. And then module names. Okay, we want module names. Yes. Okay, this is only a skeleton and output format. So if I specify -c, that is class, it would draw a diagram like this, with all the attributes. With k, it would draw only the skeleton, that is k, only class. Okay, so we'll proceed now. So idea is to copy the code, Tkinter code. Userly Python 3.x, Tkinter would be available. So we'll say copy -r, user lib Python 3.8 3.9, so we will use 3.8 Tkinter. Now we have Tkinter here. Now these are the files. If I open init and I can search for widget, I have a widget class that is empty and it derives from base widget pack place grid. So we'll try generating for widget Pyreverse -o PDF and then minus then file. Oh, I'm sorry. So we can go here. So if I execute from here, all the path that is embedded in the Tkinter is from the Tkinter. We don't need Python path. But if we execute from somewhere else, we need Python path. So I think it's better option that we set the Python path. So we can say export Python path equal to home temp Tkinter. This is the Python path. Python path. Okay, so I'll run Pyreverse and minus output is PDF and file is Tkinter init, and then I want all ancestors, all associated, and module yes, I want class and that is widget. We have extra widget.pdf. Actually, I can see widget.pdf. Okay, so it is not a small file. We can see it is quite big. And where are we? So this is our class Tkinter widget. It doesn't have any attribute and it derives from so many classes and everyone has long attributes. So this is what we get if we run it. Okay. So what we will do is, we will say -k, kind of, I don't want attributes, I want only a skeleton. Same. Okay, so we have a skeleton only. So this is quite neat diagram. Widget is derived from pack, grid, place, base widget, and other hierarchy. Finally, I believe MISC is the base class. It is same as what we saw here. Base widget, pack, place, grid. Okay, so this is what we get through Pyreverse. I can draw for the base widget separately. I can try for others. Kind of, I can try for option menu. Option menu. We have option menu now. Okay, so nice. Now we have widget option menu is here. It has containment of the menu which derives from widget. Option menu derives from menu button and finally from the widget. So this is kind of a panoramic view. Means we have a quite nice architecture of the option view. We can try other also like list box. So list box is in another file. If I say ls enter, then I believe color dialog, file dialog, font. Okay. So list box is in the init one. Class list box is here. We can try something different. I believe I can try another file called file dialog. So file dialog I can open now. Class file dialog is a class, and it is not derived from any other. We can see. We'll try with the file dialog. So I'll type again Pyreverse -o PDF. File what we want is file dialog, and then all ancestors, all associations, and module yes. Then class is file dialog, and then we want, let's see this. Okay. MOY module yes minus if retrieving. Okay, so we have file dialog now. So this is the class diagram. We can see here the mesh, and I don't know where is file dialog. Here it is file dialog, and then it has so many associations. So this is clumsy, little bit kind of hazy, confusing, but okay. So we'll try with K. Same thing with K. Okay, so it is better, but attributes are missing. So this is file dialog, and it doesn't derive from anyone. It has so many containments, and containment have derivation and containment. So it's a kind of broad diagram of architecture of Tkinter. Okay, so this is what we wanted to show. Now, there is no Python code pyx, there is no pyx file. So we'll just say py star. Okay, there is no anything other than py. Okay. So there is no Python code. Now we will use fix modify for the beautification. Okay. Now I'll say copy fix modify here. So I have a script called fix modify, and fix modify script is kind of, it calls Pyreverse. Okay, it calls Pyreverse. It's minus f all and asm yc and so many things. So why we can run like this Python 3 fix modify. Okay, so this is the option. First is fixing the Python code that we don't need, and then we will modify. So I am going to kind of I'll say Python 3 fix modify. So Tkinter, and in Tkinter init, inside the init I want for the base widget. So fix modify file name and base widget. Okay, so it is not executing. I have to provide what I want. I want modify. Fix modify, it runs in two modes, fix and modify. I want modify file name and class in the file. Okay, so it is generated. Okay, it did something. I can say ls and okay, I have a file called Tkinter PDF. Tkinter. This is what it drew. So we can just see events Tkinter.base. Okay. So this is what we get through beautification. Now I can see that base widget has, so this is a skeleton diagram. This is a skeleton diagram plus attribute. This is what we don't get in the typical Pyverse. Now I have all the attributes in one go. Okay, there is no derived class. So for derived class we have to get the code for the derived class. So I try with the widget. I can try list box. Okay. I can try base widget again. Now it would generate some derived classes. Okay. I can try now events Tkinter.base widget. Okay. So there is a difference what we saw last. Now we have base widget and we have Tkinter and list box. So we have base widget and we have Tkinter widget list box. This is certainly a information gain what we get through Pyverse. So base widget has attributes and it has set of derived classes that it is now listing. And we have a skeleton. So neat and rich in information. So that is the idea. Okay, I can try others also. What we did, fix, modify, Tkinter and then file dialog. Last is file dialog. Okay, so ls events Tkinter dot file dialog.pdf. Okay, what a diagram. Now we have all the attributes of file dialog and then it is a skeleton. It is better than what we thought like this. If in Pyverse we get a skeleton or we get everything. Here I get a skeleton and only the attributes of what we want. Okay, so these are the idea. I can try for the widget. Oh, I think we have the widget. Enter widget. Okay, so nice. And widget doesn't have any attribute. This proves. So only widget class and so many attributes. Okay, so for everything what we want, so what I can do is I can remove everything and I can just fire now Python 3 fix modify. Oh, sorry, so I copyright fix modify. So Python 3 fix modify Tkinter, that's it, and I'll say just go. Okay, 154 classes found. Now it would do for every class, and then it will generate final derived classes and everything. Okay, so it would take some time, I believe around 2 to 3 minutes. So this is the way, kind of, for a complete tool, we can just start the Pyreverse process, giving the root directory, and then it would start generating the UML diagram. Okay, so it is pretty near to finish. Okay, now it is generating the, it is fixing the all the subclasses, and it would generate PDF now. Okay, so it is done. So we have lot. We can browse like pained window. Tkinter dot. There is no pained window. So is there? Tkinter dot pained window. Oh, so nice it is. And if I see pained window, then so this is pained window, and it has a subclass called Tkinter TTK pained window. Now we would try the much awaited base widget, Tkinter dot base widget. Now we can see that there is a list of subclass now. Now we have TK base widget that derives from MISC, and it has properties, and then it has a list of subclasses that is listed by this tool and subclass. So red color shows that this class has a subclass, and whereas black shows the leaf. So that is the idea. So everything is being listed. Okay, so we can see other also if we want, like option menu, the way we talked. Okay, so option menu has no subclasses. So we'll try menu button, or we try widget. Oh, so widget has these many subclasses. It's clearly visible now. Mr. Widget has these many subclasses. So nice it is. It is a kind of a skeleton plus property plus subclasses. So we were talking about menu button. So we'll try menu button. Tkinter menu button. Okay, there. So menu button derived from widget, and it has init as a function. There is nothing more. and then it has two derived classes. This is how it is. We can club everything together in a PDF file if we want, and actually we have Pyreverse Tkinter, and here I can have all the classes of the Tkinter so nicely generated. I can search for menu button, menu button, okay, and it comes. I can search for widget and it comes. There is two widget, TTK widget and this widget. We'll try another one. Here it is. Base widget. This is what we want. Base widget. It has so many derived classes. So we can club in a PDF file. I can have list box. List box. Okay. So list box derives from XView and widget, and we have list box. It has property and there is a dummy list box that derives from it. I can search for file dialog. It doesn't derive from anything, but see the quality of the UML diagram we have. Okay, so we can draw like this. So many diagrams. See the panoramic. So nice. Pyreverse that generates UML diagram. It actually makes sense on Python. Python is not a kind of very highly static binding language as C and C++, where we first declare the signature. Like for C, if I see the structure declaration, then I know that what is the type of a structure, how much, what are the fields, and this kind of a skeleton I can understand. Or if I see in C++, if I see the class declaration, that is a kind of mapping of a structure in C, then I can understand the skeleton of the class. Unfortunately, that is not available in Python. So in Python, there are two data structures that come full-fledged into the Python. One is class data structure and one is class instance data. That is one thing. Second thing is everything we can delete dynamically, everything we can attach dynamically. I mean attributes to the class data structure, attributes to the class instance data, everything is dynamic. So when I look at the Python class, it would be empty, means there is nothing. Even Python class can be created through type built-in function. So there is nothing, there is no skeleton. Everything is added at runtime. You can add in init or you can add later. So Python has problem as far as compile time is concerned. Things are added at runtime, and by class attributes or class instance attributes, everything is scattered in the code. It's quite different than any static program. So it really makes sense to have a class diagram, class attributes, class operations, functions in one go. It's like a C++ class declaration. So we showed the Kiwi, we showed the Pyreverse on Qt, QML code, I mean Python Qt, and Pyreverse we showed on Kiwi, Pyreverse we showed on Tkinter. So it draws the skeleton of the class. That is highly helpful. One thing. Second thing, we have add-on on the Pyreverse. Now, in addition to the base classes, we have now derived classes also. All derived classes of a class we have. So when we run Pyreverse plus our tool, then it draws a neat diagram of class, its inheritance, its containment, and complete derivation. So if you are looking for generating reverse engineering or generating UML diagram through reverse engineering of your Python code, please do contact us.